Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi. We continue with our topic of discussion in Form 4 chemistry. The topic is acids, bases and salts. So today I would like us to discuss the properties of acids. So to discuss the properties of acids and basically the chemical properties, the first property is that acids react with metals, especially the ones that are moderately reactive, react with moderately reactive metals to form a salt and hydrogen gas. So when acids react with moderately reactive metals, we form a salt and hydrogen gas. And basically what we are saying here is that not all metals react with acids. We have some metals, especially those ones below hydrogen in the reactivity series. Those ones do not react with acids. It's only those metals that are above hydrogen in the reactivity series. That's why we're talking about the moderately reactive metals to form a salt and hydrogen gas. Now in this reaction, effervescence is observed. Effervescence is the hissing sound that is produced when there is a gas that is being produced. The hissing sound that tells us that there is actually a gas that is being evolved. So in this reaction, the effervescence is as a result of the hydrogen gas that is being produced. So effervescence is observed due to evolution of hydrogen gas. And the faster the effervescence, the faster the reaction. So if there is a lot of effervescence being observed, then that means that reaction is faster. But if effervescence is slow, that is just a few bubbles of a gas are observed, then it means that that is a slower reaction. Now, so we'll take some examples of a metal such as magnesium reacting with dilute hydrochloric acid. And on this, we get magnesium chloride, which is a salt plus hydrogen gas. So magnesium plus hydrochloric acid, we get magnesium chloride and hydrogen gas. So every time we are using hydrochloric acid, we get salts that are referred to as chlorides, hence magnesium chloride. So what has actually happened here is that the magnesium has replaced the hydrogen in the hydrochloric acid so that we have formed magnesium chloride. And then the hydrogen that has been displaced is the one that forms the hydrogen gas. So to balance the equation, we have two hydrogen, just like the other case. Then we put the states. Magnesium is a solid. Hydrochloric acid, we are using it in aqueous solution. So magnesium chloride will be aqueous and hydrogen will be a gas. So in this case, there is evolution of hydrogen gas. Another example, we'll take a metal such as zinc plus sulfuric 6 acid, where we shall get zinc sulfate plus hydrogen gas. So that equation is already balanced. So what we can see is that the zinc has replaced the hydrogen, has completely replaced all the hydrogen atoms that are in the acid to form zinc sulfate. And the hydrogen that has been displaced is the one that forms the hydrogen gas. So that is a solid. This is aqueous. We have aqueous and we have a gas. Now, how can we know that the gas that is actually being produced is hydrogen gas? So we look at the chemical test. Chemical test for hydrogen gas. And what we can actually say is that hydrogen gas burns in air with a pop sound. So that is the chemical test for hydrogen gas. That hydrogen gas, when burns in air, or when it burns in air that is rich in oxygen, there is a pop sound that is produced. And that pop sound is the one that indicates that the gas is actually hydrogen gas. So what we are basically saying that is that anytime an acid reacts with a metal, there will be the formation of a salt and a hydrogen gas. We can also take another property, and this is acids react with bases to form a salt and water only. So when acids react with bases, we form a salt and water only. And this type of a reaction is called neutralization. This type of a reaction is called neutralization. In other words, we are saying that the acid is being neutralized. The base is being neutralized. So in this case, we are forming a substance or a product that is neutral. So some examples, we can take a base such as sodium hydroxide plus hydrochloric acid, and on this again the sodium replaces the hydrogen, so you get the sodium chloride, and the displaced hydrogen combines with the hydroxide ions to form water. All of them are in solution form, and the equation is already balanced. We can take a different acid. We can take sulfuric acid plus potassium hydroxide. And here we shall have potassium sulfate plus water. So sulfates are salts formed from sulfuric acid or from sulfuric 6 acid. So to balance the equation, balance the potassium to balance with that, and also the hydrogen to balance with this. So we have to make sure that every time we write an equation, that equation is balanced. That equation is properly balanced. The third property is that acids react with metal carbonates or hydrogen carbonates metal carbonates or hydrogen carbonates to form a salt, water, and carbon 4 oxide. And carbon 4 oxide gas. So acids react with metals or with metal carbonates or hydrogen carbonates to form three products here. There is a salt, there is water, and there is carbon 4 oxide. Also in this reaction, effervescence is observed. Effervescence is observed due to evolution of carbon 4 oxide. Due to evolution of carbon 4 oxide gas. So that is another reaction that shows that there is a gas that is produced, and that is why the observation that is made, there is effervescence. Every time there is a gas being produced, there is effervescence. We'll take some examples. So you can have magnesium carbonate. This one is a solid because it is insoluble, plus nitric 5 acid. And on this we'll have magnesium nitrate as the salt. There will be carbon 4 oxide plus water. So basically, there are three products there. To make sure that the equation is balanced, we'll balance the hydrogen and also the nitrogen and the oxygen. And the equation will be like that. So here we are forming a salt. A salt that comes from nitric acid is a nitrate. So nitrates are salts obtained from nitric acid. Then there is carbon 4 oxide plus water. Another example, we can have calcium carbonate plus hydrochloric acid. And here we shall have calcium chloride plus carbon 4 oxide gas plus water. So basically that, then you balance the chlorides and they are balanced, and that is it. So in each of these, there is carbon 4 oxide that is being produced. So it is important to also understand what is the chemical test for carbon 4 oxide. What actually tells us that the gas being produced is carbon 4 oxide gas. So if we take this carbon 4 oxide and then we bubble it into calcium hydroxide solution, we form a white precipitate. So we can say that carbon 4 oxide forms a white precipitate with calcium hydroxide. So when it is bubbled into calcium hydroxide solution, it forms a white precipitate. And that calcium hydroxide is also what we call lime water. So when the gas is bubbled into lime water, it forms a white precipitate. And what happens is that the equation for the formation of the white precipitate is that the carbon 4 oxide is a gas plus calcium hydroxide solution forms calcium carbonate, plus water. And this calcium carbonate is now the white precipitate. That is the white precipitate. However, if excess of carbon 4 oxide is added to the white precipitate dissolves to form a colorless solution. So you can say that, however, when excess carbon 4 oxide is bubbled into the white precipitate, the precipitate dissolves into a colorless solution, or to form a colorless solution. So this is actually what happens, that when calcium carbonate plus water, which are the products of the first equation, then we add excess carbon 4 oxide, then we end up forming calcium hydrogen carbonate. So we end up forming calcium hydrogen carbonate, and this one is a colorless solution. So we get these are colorless solution. So basically, we have seen the three properties of acids as they react with metals, as they react with bases, and as they react with metal carbonates and hydrogen carbonates. So an assignment. So the assignment, the first question, complete the following chemical equations as indicated. And then number 2, what is the test for hydrogen gas and carbon 4 oxide gas? So we'll stop there. Until next time, goodbye.